Hi friends, welcome to the Cybersecurity Foundational Training Program. We are still at section 1, the IT fundamentals, and we will be treating topic 2, computer component, on a very high level. We'll start with the hardware, and then we talk about the software and operating systems. Then we treat application software, and we go through the networking basics. We touch database fundamentals, also the storage concepts, and then we look at the virtualization and cloud, and we wrap up this section with the security concepts. Hardware, software, and operating system. Let's know their meaning. So what is a hardware? When we hear about ware means product or goods. So when you hear warehouse, means a house where product or good is being kept. And now let's come back to what a computer hardware is. So a hardware is a physical part of a computer, such as the CPU, that's the central processing unit, the monitor, mouse, keyboard, hard drive, graphics card, name them. So when you hear about hardware literally means anything you can touch on your computer, anything. So when you touch your keyboard is a hardware. When you touch your mouse is a hardware. When you touch your monitor is a hardware. Anything at all, your printer also hardware, your speaker hardware. So that is just the literal definition of hardware. Anything that you can touch on a computer is known as hardware. And then, what is a software? What is a software? A software is a written set of instructions that tells the computer what to do. That is just what software is. So if there are instructions given to a computer to do a particular activity or to carry out a particular action, that instruction is known as a software. So for instance, the TikTok we are using is a piece of instruction. Okay, the TikTok is built on the user can create a video, the user can like a post, can comment, can follow. All those set of activity, all those set of action are known to be instructions, and these instructions is compiled together to make a software. So when you hear someone say software outside, what comes to your mind should be, it means set of instructions. That is what software is. Set of instruction. It is written. Now, what is now operating system? Operating system is also a set of instruction, which is definitely the definition of software, which run on hardware. So the software is a written instruction that tells the computer what to do. The operating system itself is also a software, but what it does is that it runs directly on the computer hardware. So the hardware itself now is useless without an operating system, meaning that application cannot run directly on your laptop or your computer system. It must need an operating system for it to run. So your TikTok, your Facebook, your Instagram cannot run directly on your iOS device, maybe Apple, or your Android device like Samsung or Tecno, without an operating system. So that operating system is the Android and iOS I mentioned earlier. So an operating system supports a computer's functionality, that is functions, such as executing application. Like I said earlier on, without an operating system, you can't run your applications. Controlling peripherals. So when you hear peripherals are hardware components that are not part of your computer. For example, a printer is a peripheral. A printer is a peripheral, meaning that it is not part of your computer components. You attach it, you connect it to your computer to print. And I believe none of you have gotten any computer system, and maybe as you open the computer, you see printer inside it. No, it's a separate hardware component. So when you hear peripheral, just know that it is a separate component that is not part of the computer, but it's an hardware. So if you buy an external mouse for your laptop, that external mouse is known as a peripheral. When you buy an external keyboard for your laptop, that external keyboard is known as a peripheral. So even for those peripherals to work properly, there must be an operating system that controls the functionality of those peripherals, either from your laptop or the peripherals itself. So for you to print on your printer, you must have an operating system. So your application does all the background operations or activity and send it to the operating system to communicate with your peripheral and control your peripheral. Say, oh, hey printer, I want you to do this. That person that is that functionality that is saying, hey printer, I want you to do this, is not your application. It is your operating system. Without an operating system, everything about your system, about your laptop is useless. And that's why if an hacker want to hack your system, they go straight directly to your operating system, like your Linux system, like your Windows system, your Unix system, your Mac system. All these are operating system. They don't have most of the tough hackers, they don't have time to hack your application, because if they hack your application, it's just that layer they can actually control. But if they hack directly to your operating system, they control everything on your system, including your application and your computer system itself. So an example of operating system is, we have the Windows, we have the Mac OS, we have the Linux, we have Chrome OS, and this Chrome OS is not even really popular, but it's actually an operating system. We have Android. So for the Windows, Mac OS, Linux, these three are very popular around computer system, while the Android and iOS are popular around the mobile system. That's your mobile phone. We have Unix too, and we have BSD. So looking at this diagram, if you can see this diagram, you can see that let's take our hardware, computer hardware. Now for our computer hardware, the operating system sits on the computer hardware. So when we have our laptop, we have our desktop here, then the Mac OS or the Windows OS, which Mac OS represents operating system for Apple products, while the Windows is for Windows products, Microsoft products. So the operating system must sit on the computer hardware first before we can now install applications. So we can install our Word, Microsoft Word, PowerPoint, Chrome, TikTok, etc. So this is the interconnection of the hardware, operating system, and the application before the user can use it. So without this, without the operating system, there's no way we can use our application. So please take note. Application, networking, and database. So we are going to treat this, and first we'll treat application. So what is an application? An application is a program. So when we talk about program is a set of instructions or combination of programs. So combination of sets of instructions designed for user to perform certain tasks. That is just basically what application is. So an application is a subset of a software. So software is just like a general name for both application, programs, and even operating system. So application itself now, most of the time applications are combination of instructions. So an example of application is Microsoft Word, Excel, PowerPoint. Even your social media applications, we have TikTok, Instagram. So when we talk about set of instruction, for example, TikTok, we have various sets of instruction, which makes it, when you combine those instructions together, makes it an application. So what are these instructions? The first instruction is, oh, I can like a picture. Oh, second one is, oh, I can upload a picture. I can upload a video. Third is, I can join a live. I can follow. I can delete user. I can add user. Those are sets of instructions that an application gives out. A set of instruction that TikTok gives out, which justify the definition for an application. So if you look at it, we have software. And I said software is just like the modern name for both applications, operating system, program. And software is anything that runs inside your computer. Anything at all that runs inside your computer is a software. So looking at this, we have the device hardware, like I showed earlier on, the operating system and the applications. And I said something. I said an application will never run if there's no operating system. An application will never run if there's no operating system. And I also said that hackers will always go for operating system, because when they are in charge of your operating system, they can control everything about your computer, both your hardware and even your application itself. And if you look at it, this is where application sits on. It sits on the operating system. Before user can even use this application, it has to sit on the operating system itself. So we have an idea of what our application is. Now let's go to what a networking is. Networking involves hardware. So when we talk about hardware, we're talking about routers, switches, hub, etc. Please don't worry, we will still treat that separately. This is just an overview. We will still go in depth into networking. So we just want to know what networking is, and we said it involves hardware and also software. So when we talk about software, we talk about protocols like TCP and IP. IP is the internet protocol. I also I'm giving you my words. You are going to also know the meaning of this. We're going to go in depth on this. So just for you to just have this overview of what this means. So networking involves hardware and software to connect devices, enabling data sharing. Basically, networking is the connection of devices that enables data sharing. So, and for us to achieve networking, there must be two factors in place. One is the hardware, and the second is the software. So that is just basically what networking is. So a preamble of it is a laptop or a desktop seen here. This desktop want to connect to other desktop and maybe a printer. What happens? This hardware you are seeing here is known as a switch. So the computer itself connects to a switch. This switch now connects to the other computers and the printer. So if you look at it, by the definition of network or networking, this switch has fulfilled the purpose of the hardware. This particular switch has fulfilled the purpose of an hardware. Then this line you are seeing represents the TCP and IP. So there will be a sort of configuration for it to connect to this hardware. So please don't worry, when we start treating networking, you will understand this better. This is just an overview. So the next is database. We want to know what database is. From the name database, we can split it into two. We have data and we have base. Now, what is data? Data is the collection of facts, such as numbers, words, measurement, observation, or just description of things. So when we say description of things, let's go in a simpler format. So what is a description of Ifeoluwa? So my own description, my name is Ifeoluwa. My age, I am 100 years old. My height, I am 2 feet tall. My weight, I am 700 kilogram. So looking at, if I submit this this information about me, I've submitted the data. So Other information like your other what do you call it, information like your picture, your images, your file, your PDFs are also considered to be your data. So your CV, your resume you'll be submitting is a data. Your academic certifications, they are all data. So when you hear data, just don't take it as oh something very big. It's just basically description of a thing, basically collection of facts. So if you say oh my dog name is Kemi, for example, so that fact you stated is a data. Any word you speak is also data. Any measurement you take is also data. So just take note of what data is. Now, what is a base? When we say base, basically means our foundation, central location. So if, even when we use the slang in Nigeria, we say alpha guy, where you dey? I will say I dey my base, meaning I'm in a central location. I'm in my house. I'm in my hub. So if you combine these two now, database, if you combine data and base together, the definition of database is an organized and systematic collection of data. Let's not use big grammar to confuse ourselves. Basically, this database is just like will I say a place whereby you arrange those data that is being shared. You arrange it and put it in a place. That is what database, this systematic collection, is they are all grammars. So you create a place and collect all those data and arrange them properly in a well-structured manner. That place you arrange and store those data and that place you created and arrange those data and store that data is known as database. So database can be accessed electronically. So unlike warehouse, whereby you can just you can go physically and maybe take your goods or store your goods, database does not need you to go. There's no physical place that you just go and maybe you start you take your name or you picture you uploaded, you carry it physically. There's no physical place. The only way you can access your data is through electronical means. Yes, there's data center, yes, but when you want to, where the data is stored itself is in those components of the data center. So you cannot go to a data center and say, okay, I uploaded my picture. You now go and collect the hard copy of that picture from your data center. No. Even if you have a data center, you have a database, you will still need an electronical means to access it. And that electronical means, remember I said computer is an electronic device. That electronical means can only happen via a computer, through a computer, because a computer is an electronic device that also, store data, collect data, process data. So from the definition of a computer, we can also say that computer is a vital component in accessing our data in our database. Now you can see the connection, the link. There's a need for you to understand what computer is so that you can also understand what the operating system application and even database is. Storage and virtualization. What is a storage? In a simple definition, storage is a place in your computer where data is saved. That's just a simple definition. It's a place in your computer where data is saved or stored. So it could be a simple hard disk drive, which is HDD, or a solid state drive, which is SSD. We will treat this HDD and SSD when we go deep down into storage itself as a topic, as a standalone topic. So in IT, storage is another extended component, which is a collection of multiple redundant disks. So when you hear redundancy in cybersecurity or in IT, it means extra copy of a particular system or a spare copy. So in cybersecurity, when we're talking about disaster recovery, maybe business continuity, you'll be hearing a lot around redundancy of a system, the hearing RAID, different terminologies. So for now, just know the basics. Just know that redundancy in IT means extra copy, spare copy. So in IT itself, as you have your system, storage is just one hard drive. But in IT, storage is multiple disk, multiple hard drives put together, and it is used to store large volume of data. Not just large volume of data, it even help in backup system. So please don't bother yourself cracking your brain over all this. When we go into cybersecurity proper, you understand this. But just put in mind or keep in mind that redundancy is known as extra of a system, extra of hard drive, or a spare copy. So if you can look at this picture here, you can see that this is an example of this one that has a red dot. It's an example of HDD, which is hard disk drive, while this flat here is SSD. So in simple terms, if we are to contrast or to put together, we can say storage is a place where data is being kept, while database is a highly organized system for managing that data. So database is also located in a storage device. So, but what database does is to organize those data to ensure that it is well structured for accessibility. So if you want to access your data, you can know the right place to go. But if your data is scattered everywhere in your storage device, it's not going to be easy to collect. It's not going to be easy to process. So database helps in that in data management itself. It gives that structure. It's just like having a table whereby you're able to arrange, when you create a table, you have your header, which is your Excel sheet. You see, you have your headers for each column, your name, your age, your name, your age, and your height. So the database will give you that structure of a table, your name, your age, and the height, and put in the name column, it's going to put, for example, number 1, Ife, age 100, height 2 feet. Number 2, Michael, age 3 years old, height this. So that is how database does. It helps to organize that data that is being stored in your storage device. Now, what is virtualization? Virtualization is a way to run multiple virtual computers on a single physical computer. This virtualization is what we'll be needing when we are trying to install our cybersecurity tools. For example, maybe an extra operating system or an extra cybersecurity tool. Where here, Kali Linux. Kali Linux is an operating system and a distro of Linux itself. You hear Ubuntu, you hear Parrot. So virtualization will help us run virtual computers on that single physical computer, because if you don't run a virtualization, if you don't run virtualization on your system, you can't add other operating system, or you cannot add other computers or other machine that will be running. So for example, now when you purchase a Windows laptop, without virtualization, you can't put Linux on it. You can't install Kali Linux or install Ubuntu or Parrot. You can't install even an extra Windows. Maybe you want to downgrade to Windows 9 or Windows 7 or Windows 8. For example, I'm just giving an example, or Windows XP. So without a virtualization, you can't achieve that, because virtualization gives you that it gives you that opportunity, or gives you that permission to run multiple computers on one single computer. So it helps to properly share resources among operating systems for proper utilization by the application itself. I will show you a demo of what this means. So it is like a powerful house that you divide into several apartments, where each apartment, which is the virtual machine, has its own living space and functions independently. even though they all share the same physical building and resources. So it's very simple for you to understand. Virtualization just turns your computer into a house that has other rooms for rent. So you will not just be a landlord occupying all the whole compound. Virtualization gives you that opportunity to build other apartments whereby other people can come and rent. So those other people that comes to come and rent are the operating system itself that can be on your system. And that's why when you get your laptop, a Windows laptop, through the means of virtualization, you can have 3 to 4 operating systems on that Windows laptop. Now, this is an example. Without virtualization, this is how your system is being structured. You have your physical server or your physical machine, which is Dell or HP, that's your laptop. Then the next is your operating system, which can be Linux or Windows, and then your application. This is how normally your system is being structured. So if you look at it now, we have 60 gigabyte RAM and one CPU. So if the operating system sits on your physical server, maybe your operating system will just need only 4 gig and 2 CPU, and your application needs only 2 gig and 1 CPU. At the end of the day, there is going to be a wasted resource. What do I mean? So if you do the simple math here, the total resource, which is your physical server resource, this is 16 gig RAM and 4 CPU. Now, the resource that is being used, you are going to add both the operating system resource and the application resource. So the operating system, we have 4 gigabytes and 2 CPU, that's 4 gigabyte RAM and 2 CPU. And also the application here is using 2 gigabyte RAM and 1 CPU. If you add these two together, 2 plus 4, you have 6 gigabyte RAM. And if you add 1 plus 2, you have 3 CPU. Now, if you look at it, at the end of the day, you see that when you want to now calculate the total resource, that's the resource not used, you will say total resource, which is the 16 gigabytes and 4 CPU, minus the resource used, which is the 6 gigabyte RAM and the 3 CPU. At the end of the day, you will see that the resource that is being wasted or not utilized at all is 10 gigabytes and 1 CPU. With virtualization, we'll be able to solve this problem. With virtualization, we'll be able to solve this problem. Now, how does virtualization solve this problem? Now, look at this here. So we have physical server, which is your computer, for example. Now, you first install your virtualization. So you install your VMware or your Oracle virtualization. Please don't bother yourself. Don't think too much about this. We'll still reach a time. There's a separate class for virtualization whereby we teach you how to install your virtualization and also install your operating systems, various type of operating system. So we still have a practical session for this. I just wanted to understand the usefulness of virtualization. So now you first install your virtualization, you first run your virtualization on top your computer before you can now install your operating system. Now with virtualization, it will give you opportunity to install varieties of operating system, even up to 4, 5, 6 operating system. So if you can see, we have one operating system here, which is app OS1 app 1, OS2 app 2, OS3 app 3, OS4 app 4. So we can say, okay, this OS now can be Kali Linux. The app I'm going to put on there on it is Bob Suit. We can say, okay, this other OS is going to be Windows, maybe Windows XP. The app I'm going to put there is Microsoft Word. This one is going to be Ubuntu. The app I'm going to put there maybe also maybe John the Ripper. The OS here maybe can be Parrot. The app we can put there, maybe we'll just look at installing maybe an hacking tool. Now, if you now go, what does this now do for us? Now, if you look at it, we have, for example, the physical server is being assigned 16 gig RAM. So if you look at it now, this physical server now is assigned 16 gig RAM and 4 CPU, just like the way we had this here, just like this. So you see the physical server here, we have 16 gig RAM and 4 CPU. here also we have 16 gig RAM and 4 CPU. So what happens here is that when we install this virtualization can now take the capacity of your physical server. So it will also take the 16 gig RAM and 4 CPU. So it's like a transfer of capacity to this VM here. So what does virtualization does? It now helps in the proper what do you call it, distribution of resource. So what it will do now, it can now share maybe 4 gig of RAM and 1 CPU to this 4 what do you call it, 4 OS each. So if you look at it, you have 4 gig RAM, 1 CPU for OS 1, 4 gig RAM, 1 CPU for OS 2, 4 gig RAM, 1 CPU for OS 3, 4 gig RAM, 1 CPU for OS 4. So this virtualization helps us in that proper distribution of resource. So now if you multiply 4 times in brackets 4 gig RAM plus 1 CPU, what do you have? 16 gig RAM plus 4 CPU. This is what virtualization can give, can help you achieve. Without virtualization, you cannot properly utilize the full capacity of your machine as displayed here. So this is just it, and you can see all resources fully utilized through the help of virtualization. Just like a recap, the virtualization takes all full resource of the computer and properly distributes those resources to the operating systems. Here we have 4 operating systems. So 4 operating system is being created, and there's a proper distribution of the resource to those 4 operating systems with the applications. Lastly, cloud and security. What is a cloud? Cloud computing is the on-demand availability of computer system resources like storage, software, processing power from remote servers instead of your own local computer without a direct active management by user. So I want to break this down a little. So there are keywords we need to look into. The first is the on-demand. We say cloud computing is the on-demand. So when we talk about cloud, we're talking about cloud computing. And the first thing was on-demand availability. So what does this mean? It means that unlike the traditional way of we setting up our IT environment, whereby those days we want to set up our IT environment, we use what they call the on-prem structure. So on-prem means every IT setup we want to do is going to be in that physical location. So unlike those days whereby we will get everything down, our server, our database, we have to buy everything and keep down. Cloud gives you the opportunity to request on demand. So if you don't need a particular server, you don't need to buy it down. Unlike those days, you will have to buy everything. You have to buy everything down. But in cloud, when you need it to perform a particular task, when you need the particular resource to perform a particular task, you can immediately ask for it or request for it or apply and get it. You get it instantly. So it is already available. The provider has provided those resources on ground. So your server, your database, everything is on ground. It's just for you to just demand for it, request for it, and you get it delivered to you. So the first point there is on-demand availability of computer system resource, meaning that the resources that normally you would have built on your physical location, you don't need to build it when you don't need it at that moment. The moment you need it, there's someone somewhere else that has built that resource, that has that infrastructure on ground. It's just for you to contact that person to say, oh, Mr. A, please, I need 2 servers from your hand. The person will definitely now provision those servers to you. So when you get provisioning, means that it will set you up on that particular resource you asked for. That is what that on-demand availability of computer system resource means. So when we talk about storage, we talk about storage already. Storage, software, processing power. Processing power includes even your CPU. That's the way your computer thinks. Processing power, your CPU itself can also be what do you call it? Be provisioned to you. From take note of this, remote servers instead of your own local computer. So for you to now access those resources, you have to connect to it via internet. So there's no way you can connect to it if you don't have what they call it. There's no way you can get those resources if you don't have a connection. And that connection can be done through internet. That's remote servers. So don't bother yourself about the complex word or remote server. We'll still definitely talk about it subsequently in other teachings, but remote server, just take it as internet. So all those resources can be gotten through internet without direct active management by user. I will break this. I have a breakdown of this. So when they say without direct active management by user, it means that when you have those your physical server, your database on your physical location in your company, all maintenance will be done by you. Everything, management, if you want to do patching, sorry I'm using complex words, but patching is more of like upgrading, updating a particular system. So if you want to maybe update the system, if you want to repair, all those things is not going to be done by you. It's going to be done by that service provider. That is what cloud computing is. So if I'm to put it in a layman term, I would just say cloud or cloud computing is the process of getting what you want, so the IT resources you want, from another person who has those resources available. Just by you demanding for it, you get it. And this resource can only be accessed through internet. Also, those resources that is being accessed do not need me to run any maintenance on. The person providing those resources for me will run those maintenance. That is just basically what cloud or cloud computing is. So the term is generally used to address data center available for many users over the internet. So that resource I'm talking about, so we're talking about the software, processing power, the storage, is all put into one location called data center. Now that data center is a location, but it can be scattered all over the world. So we might have up to 1,000 data centers, 700 data center, 500, 800 data center into various regions. So when we go into computing, cloud computing as a topic on its own, we'll still look into regions. So we can take AWS for example. We'll look into region and every other terminologies. So just for you to understand, that data center is a physical location and it is owned by that service provider. And that data center can be in various locations, more than 100 to 200 locations, so that it can be easy for you to access via internet. So now let's look into a proper data center. In cloud computing, what you'll be accessing, everything you'll be accessing is located in data center, like I said earlier on. And now we want to look at those things in the data center. So the first thing you look at is the server. So in a data center, you definitely get a server. Now, I said you don't need maintenance. So if by virtue you are to set up all those things, this server in your physical location, you'll be paying database or hardware technicians to maintain it, which the cloud service provider has saved you of the stress for you, just for you to just pay, just demand, pay for it, pay for your services and leave the maintenance for them. They will do the management for you. Now, in this server, we have our OS, that's our operating system, sits on this server. Also, this operating system, it needs a system administrator to manage it, which the service provider will save you of the stress if you just subscribe to it, or you pay for it, or you demand for it. Also, application itself, like SAP, Oracle itself, is now what you will be using as a user. Also, even if you're talking about the update or the upgrade of this application, you don't really need to update it or upgrade it. Is it that it can be a shared responsibility? If you want to update it, you can update it. If you want from their own end, the service provider, to look into updating your applications, some applications that you need, that maybe is being provided by them, you need them to update and upgrade it for you. They will do it. Now, the next is the firewall, router, and switches. Also, you will need a network and security administrator to handle this part. The service provider will be the one to maintain it. So you have access also to database. Now, this database itself, you need a storage administrator to monitor or to manage the database or the storage facility. This cloud computing will save you of the stress of doing those things. So all this resource, the server, the OS, the application, the firewall, router, switches, database, the storage, will be provisioned to you. Like I said, provisioning means giving, onboarded. You will be onboarded to those to those resource, if you actually subscribe or pay for it, and you will access all this resource via internet. Now, who are those cloud service providers I've been mentioning so far? We have the AWS, we have Oracle, we have Azure, we have Google Cloud Platform, we have IBM, we have Salesforce, we have VMware, we have DigitalOcean, Red Hat. We have so many of them. Alibaba Cloud. Those are the service provider, the cloud service provider that will tell you, oh, Mr. Ife, don't stress yourself. Just pay us. We will give you everything, all the IT resources and all the IT systems you are looking for. We will give you. Just pay. On demand request, we will give you. It's readily available. Don't install anything. Don't set up anything in your environment. Just give us money and we will give you access to it. Your own is just for you to subscribe to internet, have data, and access those resources and pay us to do it. Lastly, what is security? Security can be divided into two. We can say, okay, security, computer security, or the IT security. Let's look at the computer security. The computer security, from the normal, from the basic terminology, security, we can talk about computer security from basic terminologies, and IT security. For computer security, security is the practice of protecting computer system. So when you talk about computer security, we're talking about protecting computer system, including the hardware, software, and data from unauthorized access, damage, misuse, disruption. It focuses on keeping computer and everything inside it safe and functioning correctly. When we go into security proper, we will treat what security is. We look at the CIA trials and the likes. But this is just a fundamental definition of what computer security is. Now, the IT security itself, the information technology security, is the broader process of protecting all forms, not just restricted to computer, but all forms of technology and information system, such as computer, networks, servers, data, and even software, from threats and attacks. It ensures the confidentiality, integrity, and availability of information across an entire IT environment. So the availability, integrity, and confidentiality will be treated when we have our security classes. But for now, just know that IT security and computer security is just the protection of both computer system and also protection of IT system, which includes the computer server, network, and the likes, from bad people. So when we talk about unauthorized user, those are the bad people, I mean to say, that shouldn't have access to your resource or to your IT infrastructure. And lastly, so let's look at where security can be applied at some following levels. So, I said something. I said in one of my videos, I said that you can't protect what you don't know about. So now we've known some things about our computer. We let us know where we can also apply security. So we can apply security in our hardware. So most of us will be going into robotics and maybe mechatronics. You can apply security to your hardware builds, your hardware construction. You can also apply security to operating system. So most of us will become a security system engineer or system security engineer. You can also apply security to operating system. Application security engineer. You can also apply security to application. So your TikTok, that's your mobile application, your web application, you can apply security to it. Network security engineer too, you can apply security to network. Even storage, database, virtual and cloud. So definitely those of us that will be going into cloud security, you have to also pay attention to what cloud entails. This definition of cloud, we're going to still go in details as we progress in our class. So when you understand how cloud works, then you can now bring in security to protect cloud. So we've come to the end of today's segment, today's topic, and we'll meet same time in the next training, which will be talking about the topic 3, and that will be shared in few days from now. Thank you everyone, and God bless you.